Hello guys, welcome back to my YouTube channel. This video is going to be a run through of a computer vision application. So far what we did was to create a new data set. This is Google Cloud Platform. We have created a new data set, and after creating the data set, which is actually this one, we got the import tab and we uploaded images from our computer for the model training. Then we came here over to this tab and we picked each image and labeled them by drawing annotation boxes around the coins that we want to identify. The next thing we did was to train the model. So after training the model, we were able to get the results, which I'm going to open from here, model registry. Yep. So this is the model that we trained. The next thing on the plate is to deploy and test our model. Now you can't really test this model without deployment. So we're going to click on deploy to endpoint and we're going to give it a name, and location is Europe West 4, which is selected by default. Now we have standard access. I think most of the things that we need here will just be by default. So just click continue. Traffic split. Now traffic split means that if you have other models that you want to deploy on the same endpoint, because that is actually very possible, then you have to ensure that the traffic is split in such a way that at the end of the day, all the endpoints use a total of 100% of, all the models use a total of 100% of this endpoint. So in this case, we have just one model that we want to deploy. Then we move on to every other thing. So I enable access login for this endpoint. Yeah, that's fine. So we'll click on done, and I think that's all. Then we click on deploy. So for the particular project you're working on, you can get the billing for that project. Right now, as you can see that I'm still running £0, and that's because I still have my free credits. Okay, so don't forget that except you have actually started a live project and you are aware that you're going to spend money for that, then that's fine. Otherwise, just keep an eye on this. Okay, all right. Okay guys, so the model has been deployed to the endpoint, and now we can test it by just uploading an image. Just a reminder, your test image or whatever image you want to pass through this model or you want to use on this model, make sure that you pass it through the same pre-processing steps that you used for the training data set. So you do the same thing for the images that you want to test or any images that you want to run predictions on. I'm going to drop a link to the GitHub account, which the GitHub profile, the GitHub repository, which I shared earlier when we were doing pre-processing. So I'm going to drop that same link. So to pre-process your test images, I have a folder here called test images, and I have added all the test images that I want to use. So I did the same thing. This is the pre-processing file. So you change the name of the folder that you want to use to test your images, change it to test images, output folder, change it as well. Then you run this particular file or this particular script. So I'm just going to do that. Then you open your terminal and you run Python 3 process.py. So here we have the resized and cropped image. Okay, so we'll come back here. So let's see, I think let's try the 5p. Let's see. Okay, so there are some predictions on the right hand side here. You can see that it is predicting 5p with 77%, and then there is 10p as well. And yes, actually 5p and 10p look alike in a way. Then very low values for 1p and 2p. So what would happen is that you pick the prediction with the highest percentage value. The next thing we want to do is to use this API in an application, either a web app, mobile app, or whatever you want to use it for. Actually, it's just an endpoint that you can access through an API request. So let's just see a sample request here. There's the REST API, and then there's the Python sample request. So you have to follow some instructions to set up, and I'm going to talk about that once we get into the Flask app. But for now, you can also do this by following the setup instructions in the Python client for Cloud API platform Quick Start. Okay, so you do all this. So there's some authentication you need to do here. You need to set up a virtual environment. We already did all this virtual environment setup when we started the app. So we are going to skip that. Then the next is to copy and paste sample code on GitHub into a new Python file. So this sample code just shows a function that you can use to access the Vertex AI endpoint. We'll copy this and paste it in one of our files. So it says predict image object detection. It takes the project ID, endpoint ID, the file name or the file path, location, and API endpoint. By default, you can see that on the documentation, the location is US Central 1. That's the default location. If you are not using the default location, ensure you change it, just like I've changed mine. So 80% of the code we have in this file is what we copied from that page. I just made some changes, I think from line 22 to line 35. Yeah. So what I did is to ensure that the image is first processed exactly the same way the training images were pre-processed, and convert it to byte, and before sending it using this method predict.instance.imageObjectDetectionPrediction_instance, and this is gotten from Google Cloud AI platform. All right, this process image function we've seen this before when we were pre-processing the images that we needed to use to train our data. So I'm just going to show it in the help us function. Yeah, so we have three functions here: the process image function, the process images function. So this is what we use when we are processing images in bulk. So we have an input folder, we have an output folder. I'm just going to open this up. Yeah, I already walked us through this function. Then the third function is the get totals function, which we'll be using in the Flask app to get the total amount of money in the image. So I'll minimize that, minimize this as well. And we just have this. What happens in the pre-process is we crop the image, we resize the image, and we are making use of the pillow library as well. Now we'll go back to the chest prediction. I've walked us through this method. So we got this from the documentation as well. I'm going to go back here, go back to GCP console. So this is what we got. Execute your request in Python. In this case, the request will return a series of bounding boxes and their confidence score. So we'll come back here, call the function, add your project ID. So this project ID and endpoint ID is supposed to be a secret, and I may not be able to hide it for the entire video because it's going to take a lot of work to find where they are and hide them. Later on, for future videos, I may need to find an AI that would do that for me, check through the video and hide these IDs. Or I can just restart the project or create another endpoint, whatever would help me to get another set of keys for this project. Okay, so you have your project ID, endpoint ID, and the file name. So this is a relative file path. This is supposed to be file path, not file name, but it depends on how you set up your predict function, this predict function. Okay, so we'll come back here, and I think that's all. We are going to run this file and see the sample prediction that we get. So we come down to our terminal and run Python 3, and the name of the file testprediction.py, and this is the results that we are going to get. So this gives us an idea of what to expect. So it's actually important to do this so you know that your endpoint is okay and you are getting expected results before you go ahead to add this to your web application, so that when you're having errors, you know where exactly the error is coming from. And if you're a machine learning engineer and you have no business working on web applications, this is enough for you to give to the web application developers and tell them that, oh, this is the result, the kind of result you're expected to get from this endpoint, and this is the function to call when you need to use this endpoint. Yeah, so it's as simple as that. Now let's go and make use of this function in our Flask application. Okay guys, now let's do a walkthrough of our Flask app. The first file in your Flask app will be app.py. So our Flask app has just one endpoint. This endpoint is different from the one we got from Vertex AI for our model endpoint. This is just for the web app. Now this endpoint has two request methods. It has the get method and the post method. The get method, when you call get, it should render index.html file, which can be found in the template folder. I'll walk you through what happens when you run a post request, but for now, we're just going to focus on the get request, and we will run the Flask app with the command flask run. This is already in the README file, so in case you're lost, you can always refer to the README file. Do flask run, and our application will be on the local server, and we can open this using command click. We have this on the browser. It says my money app, select the image you want to predict. So you choose the file and then you click upload and predict. Now I'm just going to move this into the same window as VS Code. So this is what get request returns. But if there's a post request and the post request comes from submitting this form. So if there's a post request, I'm just going to do a post request. So we'll have to choose the file first. So we'll pick a file, let's say this, okay. Then we click open, and then we click upload and predict. So when we click this, the post request is called. So I'm going to open the index.html file and show you this. So this is our HTML file. We have the header or the head, we have the body, then a header for a typical website. I didn't put anything here, but you can always add something here. We have the main tag, we have the footer tag as well. So you can always update this, the header and the footer, but for now we're just going to focus on the main section of the website. So this is h1 element. This is not a HTML and CSS tutorial, so I'm not going to dwell on this. I'm just going to go right into the form. This is the form element. Now the form has a post method, and this post method is what we are going to be considering, or what we are going to be looking out for in the app.py. So just going to open app.py again. So now we're saying if the request.method is post, what should happen? I'm going to open this up. It was actually closed before by clicking this arrow. So if there's a post request on this main route, we want to do something. So what we are going to do, we get the image from the request. Then we save the image into the static folder, which is this folder here in the images subfolder. Then we make a prediction. I already talked about this function. We tested it in the test prediction file. So we make a prediction with the project ID, endpoint ID, and all that. When we get the prediction, we have to pick out everything we need from the response of the request. And that includes the bounding boxes, the display name, and the confidence levels. So the bounding boxes, let's say for instance, there are like 10 coins or maybe 5 coins in this image. We want to get the bounding boxes for all of them. Then we want to get the display name of the bounding boxes or the predictions. Then we get the confidence score as well. Confidence score returns a float number. Let's see, where is the result we got the other time? Yeah, so this is the confidence score. As you can see, it has about 5 or 6 decimal places. We want to get just the 2 decimal places. So we are going to, and that is what we formatted here. Once we get that, then we need to calculate the total amount, and this is the function that we had earlier in the helpers file. In the helpers file, you can see that we imported it up here from helpers import get total. So I'm just going to open this, minimize this, and open up the get total function. So it takes all the labels, because it takes the labels. Labels in this case would be this, an array of labels, 2p, 5p, 10p, depending on how many objects were detected. Then we look through the labels and add the amount to, and sum up the amount, while of course removing the p part of the label, and that's how we have the -1 here. Then because we want to get the value in pounds, we'll divide by 100. So that's it for get total function. We go back to our app.py. Then we need to specify image display width. Now this image display width is the width, the size that we want to display on our web app for the images. Remember that the original size of this image is 1024 by 1024, and that's too large to be displayed on a web application. So we can reduce it to 400. It can be reduced to 300, 200, whatever size that we want. So for now, we are going to be using 400. The next step is to convert normalized coordinates to pixel coordinates. Normalized coordinates because the bounding boxes are returned, because the bounding boxes have coordinates that are returned as decimal places, which like a fraction of 1. Okay, so I'm going to use a PowerPoint presentation just to show this. Okay, here is so up here is the response we get from the Vertex AI endpoint, and this is the image that we are trying to predict. Now each subarray in the bounding boxes array contains the dimensions for each object. In this case, we have just one object in this image. So there's xmin, there's xmax, ymin, ymax. Xmin means the minimum value of x, the maximum value of x, the minimum value of y, and the maximum value of y. Now when we take this value at the top and plot them on an xy axis, remember your mathematics. Now we have from 0 to 1 on the y-axis and 0 to 1 on the x-axis as well. And these are normalized values. So we have x-min value of 0.32 and y-min value of y-max value of 0.79. So this is x-min 0.32 when you trace this down here, and y-max is 0.79. On this end, we have the x-max, which is 0.68, and the y-min, which is 0.43. Okay, so I didn't actually plot this directly. Now this is me just trying to explain this as simple as I can. Now going back to the value we had as display width of 400. remember this is where we are, image display width of 400. So when we use that width to normalize this bounding box values, we are going to get something like this. So we say multiply box axis or boxes axis by final image display width, which is 400 pixels. So when we multiply 0.32 by 400, we should get 128. When we multiply 0.79 by 400, we should get 316. So similar to what we had before with the normalized values, but now we are having the exact values based on the final display image, based on the final display width of the image. Okay, so this is very important for you to understand, because at the end of the day we are going to be using CSS to position these bounding boxes on our image, and we need to understand what these values are. Now Vertex AI doesn't return your image with the bounding boxes already drawn on them. No, the only thing that Vertex AI returns is what we have up here. It's just a JSON object. So you are the one that will analyze the response and use it to do, whatever you need to use it for. So in this case, a web app that we need to display the bounding boxes. So the bounding boxes, this red line, we'll use CSS to display it on our image. Okay, now let's go back to our app. So we loop through the bounding boxes and we say for each box in the bounding box and for each value in the box, we want to multiply that value by the image display width. And at the end of the day, we have to return this to our web app on the HTML file. On this line, we are zipping the values because we want to be able to match each bounding box to their respective label and their respective score. So that's why we had to zip it in this function. You can Google more about the zip function in Python. Then we need to render that same page again, but this time around we are going to be sending the predictions value. We'll send the predictions value, then we'll send the image file part because we want to display it. And we also send the image, display width and the total amount. Okay, and that is it for the post request. So once we render this HTML file on the browser, we are checking if there is predictions. If there's prediction, then we render this lower part of the web app that contains the prediction. So we say prediction, then the total amount, which we already returned as a URL parameter. Then we also have the image part. Remember we talked about image part here, down here. Image, what is it? Yeah, image part. We'll style the image by giving it the width of the image display width we needed, that is 400. Then we style the image by giving it a width of 400, which is the image display width that we have set. Then we say for each box, then we loop through the predictions. We want to get the box, the label, and the score for each predicted object. When we get that, then we display a div element, and the div element will have a color of red. I think I'll just close this sidebar so that we can see this more. So when we let's open our CSS file. This is our style.css, and closing this. So we have the style for our bounding box here. So give it a solid border of 2 pixels and color of red. Then we give it an absolute position. Now without this absolute position, we would not be able to specify that we want the bounding box on top of the image. Okay, and this is actually the div that contains the image. When we go back here, where is the result? Yeah, so this is the result div. It contains the image and it contains the bounding boxes. So each of these bounding boxes have to be laid on top of the image. And the only way to lay them on top of the image is by using absolute positioning in CSS. I have a CSS tutorial that explains absolute positioning and all that in detail, so please check that out in case you're confused here. But like I said earlier, this is not a CSS tutorial, so I'm just going to leave this here. It will be in the GitHub repository, so you don't need to bother so much about it. We are just trying to focus on the machine learning parts. Okay, so let's go into the styling for the bounding boxes. We have a left styling because we want to specify the left position of the bounding box on top of the image, remember. Then we have the width of the bounding box. We have the height of the bounding box. So we are saying we want the bounding box to start at this left position, which is this position here. Remember that this would be x min y max from what we described here. This is x min y max, this point here. Now let's say this x min y max. So let's say this is 128. We are saying that we want the CSS to style this red bounding box 128 pixels from the left. So this is 0 pixels from the left. So we want it to style 128 pixels from the left. And we also need to specify how many pixels we want from the top. So guys, guess what the width will be? The width will be x max minus x min. Okay, this is mathematics. If someone asks you what is the width of this coin now based on this plot that we have here, it's simply x min minus x max. What's the height? Y max minus y min. Then we also need to display the label and the score, and that's what we have down here. Label is 1p and the score is, this is the confidence score of 0.97, and we also have styling for that. All these things is just to style the outcome of our web application. Without these styles, this web app would not look as beautiful it is. I hope it's beautiful. I hope so. Okay, so we'll go back to the HTML file, and I think that's it. So after looping through all the bounding boxes, after looping through all the predicted objects, then that will be the end. So I think that's all that we have for our web application. Thank you for watching and see you. Okay, that is the same thing would apply if you have multiple bounding boxes. So I'm just going to pick up a file that has multiple images in it. You're looking for an image with multiple points. Yeah, this will be very good. So click this, upload and predict. Ta-da! So we're able to detect the 5p with a confidence score of 0.99, 200p, and this is £2 with 0.99 confidence score. We have another £2. Then we have 50p. We have £1. Then we have 5p and we have 10p. Altogether, when you sum this all together, we should have £5.70. We should format this to have a 0 at the end so that we know this is 70 pence. Now this is very, very important. I said it before, but I'm going to say it again. Do not forget to clean up your cloud platform services, whatever you're using on the cloud platform, once you are done using it. Okay, so we're going to come to the Vertex AI and just close this down. And this endpoint that we deployed, in order for it not to keep running and consuming money, we're just going to come here and undeploy the model. Okay, as a matter of fact, we can just go over to billing and remove that app from active billing. So just going to come here and we click on manage billing account. This is our app. Then we say disable billing. Once you click disable billing, you will not be able to access this app anymore. So we just say disable billing. Now this brings us to the end of this tutorial, and I hope you've enjoyed it so far. You can take it a step further by deploying this to a live server. I think I would have to do another video for that, but for now I'm just going to leave this. Before you deploy it, there are some things that you actually need to do. So if you read this warning sign, it says this is a development server. Do not use it in production deployment. Use a production WSGI server instead. So you can Google this and find out how to set up a Flask app for deployment in a production environment. Other than that, so far so good. We have our web application that we built with Flask, and we used Vertex AI to do ML predictions. So thank you so much for staying with me through this tutorial, and I appreciate you. Please like my video, leave a comment, tell me what you think about this video, tell me what you need me to improve on for the next video. Let me get your feedback. I would really appreciate it. And don't forget to subscribe as well. Don't forget to share this video. Thank you so much, and see you next time. Bye.